So here's the question, is what, for the progressive creationists, what is it that they have chosen to believe is true about history that now requires them to want to look at the text differently than those who are in, we would say, the young earth position?
You know, it's interesting. Again, I like to look at it historically. So the real issue are the rocks.
When it comes to the age of the Earth, there are two schools of thought, the young Earth model and the old Earth model. Even today, people are still debating whether the Earth is young or old. Even though back in the 19th century, scientists were already beginning to question the legitimacy of the young Earth model. Scientists didn't have a reliable mechanism for dating the age of rocks until the 20th century, with the advent of radiometric dating. By measuring the ratio of radioactive isotopes, we can now calculate the age of rocks on a large scale. So how old is the Earth? Let's look at 4 key pieces of evidence that support the theory that our planet is over 4.5 billion years old. To find Earth's oldest rocks, we will need to look at Archean cratons. These are massive remains of early crust produced by Earth. The oldest rocks found within these cratons are in the Acasta Gneiss complex of Canada. By measuring the ratios of uranium, geologists have dated these rocks to an age of 4.03 billion years. The oldest minerals on Earth are zircon crystals found deposited in younger rocks in the Jack Hills Formation in Western Australia. Even though the surrounding rock is much younger, these zircons crystallized a long time ago and were recycled by the Earth's natural rock cycle. By measuring the ratio of lead isotopes in the zircons, scientists have dated these at 4.4 billion, even older than the Acasta Gneiss. There is a broad consensus amongst scientists that our moon formed from a collision between Earth and another large body, either right at or just after Earth's accretion. This is known as the giant impact theory. Using this theory, there should be a relationship between the age of terrestrial and lunar rocks, and in fact there is. Lunar rock samples returned from the Apollo missions have been dated up to 4.55 billion, using similar techniques as the Acasta Gneiss and Jack Hills zircons. With these 3 pieces of evidence, we're getting closer to understanding Earth's age, because we know Earth must be older than the rocks and materials it produced, and older than the moon. To continue constraining Earth's age, we also need material that is older than the Earth. In the 1960s, Claire Patterson began using radiometric dating on meteorites. His analysis of lead isotopes yielded the oldest age of a meteorite at around 4.55 billion years. Since then, geoscientists have continued to research the Earth's age, and today most agree Earth is around 4.56 billion years old. So when it comes to finding evidence to support the young Earth model, I think our friend from the beginning of the video put it best.
The real issue are the rocks.